Welcome to the Unit 5, Section 6 video on applications for systems of equations. All systems can be solved in more than one way. For some systems, some methods may be better than others. So let's break down the methods that we've talked about in this unit. You can use graphing if both equations are solved for y, and if you want to estimate a solution. Sometimes you'll get an exact solution because the two lines will cross at a nice clean set of integer values. But sometimes that doesn't happen. If that's the case, then you need to move on to a method like substitution. A variable in either equation has a coefficient of 1 or -1. Substitution is a good way to go. If both equations are solved for the same variable, or either equation is solved for a variable. So if you have a variable that's isolated, like an x by itself or a y by itself, then substitution may be a good way to go. And then elimination may be a good way to go if both equations have the same variable with the same or opposite coefficients, or a variable term in one equation is a multiple of the corresponding variable term in the other equation. So say in the second example here, you've got 6x and you've got 3x. Well, you know if you multiply the bottom one by 2, then that's going to give you 6x, and you'll be able to eliminate your x terms. So now that you know all the methods for solving a system of equations, we can use it when solving word problems. You can use systems of linear equations to solve some classic math problems that are common in textbooks and in puzzle books. To solve word problems, follow the 3 basic steps. Define your variables based on your unknown quantities. So you'll have 2 of them. One's going to be an x and the other is going to be a y. Write your equations based on what the problem states, and then solve using any method. So the sum of 2 numbers is 42. Their difference is 6. Find the numbers. So in this problem, we're going to let x be the greater number and y be the lesser number. So the sum of 2 numbers is 42. We can write that as x plus y equals 42. If you add your 2 unknown numbers together, you will get 42. So x plus y is 42. That's one equation. Then we also have that their difference is 6. So if we take the greater number and subtract the lesser number, then the result will be 6. So x minus y equals 6. Now we have 2 equations with 2 unknowns. We can solve this system. Since we have a plus y and a minus y, we can use elimination very easily on this one. To cancel our y's, we get x plus x, which is 2x, 42 plus 6, which is 48. Divide each side by 2, and we get x equals 24. So one of our 2 numbers is 24. Now take that 24, plug it into one of the 2 equations. I'll plug it into the first one. 24 plus y equals 42. Subtract 24 from each side, you get y equals 18. And so the 2 numbers are 24 and 18. Yuri is twice as old as Zach. 4 years from now, the sum of their ages will be 23. How old is Yuri? So let's let x be Yuri's age and y be Zach's age. Yuri is twice as old as Zach. So if you take Zach's age and multiply it by 2, you get Yuri's age. So x equals 2y. In 4 years, the sum of their ages will be 23. So if we take Yuri's age and add 4, and Zach's age and add 4, and add them together, you will get 23. So now let's take our 2 equations and let's solve one of them. We'll use substitution here. So the second equation, x plus y plus 8, because we have 4 plus 4, equals 23. We combine our like terms, and then we subtract 8 from each side, and then we can substitute 2y in for x, because x is already solved for 2y in the other equation. Combine our like terms, we get 3y equals 15, and so divide each side by 3, and you get y equals 5. So now we have Zach's age is 5, but the question asked how old is Yuri? So to find that, we're going to take that y equals 5, plug it into the first equation, and do 2 times 5, which is 10. So we have found that since x equals 10, Yuri is 10 years old. Jennifer's school is selling tickets to a play. On the first day of ticket sales, the school sold 3 senior citizen tickets and 12 child tickets for a total of $84. The school took in $76 on the second day by selling 10 senior citizen tickets and 6 child tickets. What is the price each of 1 senior citizen ticket and 1 child ticket? So let's start by defining our variables. Let X be the senior citizen ticket price, and let Y be the child ticket price. So we're going to take that second sentence and form our first equation. 3 senior citizen tickets would be 3X, and 12 child tickets would be 12Y. Add those together and you get 84. 3X plus 12Y equals 84. The second day, we sold 10 senior citizen tickets, so 10X, and 6 child tickets, so 6Y, for a total of $76. So we have 10X plus 6Y equals 76. Now that we have our system of equations, we can solve. Now we are going to multiply the second equation by 2 and solve by elimination, because if we multiply 6 by 2, we would get 12. And if we subtract the 2 equations from one another, 3 minus 20x would give us negative 17x. 84 minus 152 gives us negative 68. Of course, our y's cancel. And then divide each side by negative 17, and you get x equals 4. Now that we have x equals 4, we're going to plug that into one of our 2 equations. We'll do the first. Plug in 4 for x. 3 times 4 is 12. Subtract 12 from each side. That gives us 12y equals 72. And then divide each side by 12 to get y by itself. So we have y equals 6. So again, a word problem requires a word answer because you need context. So senior citizen tickets cost $4 each, and child tickets cost $6 each. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.